Yeah, so how can we ensure that space resources benefit all people on Earth, not just the billionaires, the owners of the aerospace companies, or the people who live in developed nations? The question presupposes that space resources will produce a gigantic benefit such that this question is important. And I'm convinced that they will. I'm convinced that this will actually lead to an economic revolution. And most of the people who work in this field, as I do, hold a similar view. The issue is that once we can unleash industry from the scale limitations of a planet, then we will have access to billions of times greater resources. And if we do this with autonomous robotic labor, and there's no limitation of real estate in space, not significantly yet, then it can grow exponentially to the point that it begins to overcome the economic productivity of our entire globe. Right now, we're feeling the effects of this planetary scale limitation. Our population is growing towards 11 or 12 billion people by the end of the century. Researchers think that it will level out at that time. However, there's an assumption that the environmental burden we place on the planet will also level out when the population does. I don't believe that's correct. It's true that economic activity is driven by intelligence, but we've already created another type of intelligence, which is doing economic activity, artificial intelligence. And the demand for that is going to continue to grow even beyond the end of the century. There was a study a few years ago that predicted the rate of energy used by computing. That prediction says that by the year 2037, computing will require as much energy as everything else already in the economy. We can delay that with more efficient computing out to about 2045. But it's not that far away. After that, the energy use in our civilization will be growing in multiples, double, triple, quadruple. There was a study a few years ago by the United Nations which did a meta-analysis of 133 other studies that were predicting the rate of growth of the global economy and energy usage. Now, the predictions were all over the map, but treating this as a statistical sample, the 50th to 75th percentile predictions, which is the yellow band, tell us that we will see an increase of energy use by a factor of 4 to 5 by the end of this century. That means 4 to 5 times as many machines burning the energy, 4 to 5 times as many factories building the machines, and the resource extraction to go along with that. So the environmental burden may very well keep growing beyond the population leveling out. But the two problems that I've just mentioned, energy and computing, happen to be the two things that are most easily offloaded from our planet into space. People have talked about space-based solar power. It's generally not economically viable right now, but when the day comes that we have factories, mining and manufacturing with space resources, then it will be a shoo-in that space-based solar power will become economically competitive. And we can also then make the computers so that the entire supply chain supporting computing in the energy sector can be offloaded from our planet. And we think that there is a beginning step, which is already happening. And that would start with mining on the moon and asteroids for water. We know that the dark craters at the poles of the moon have water ice, and it can be converted into rocket fuel. And I just published a paper 2 or 3 weeks ago that showed, I think definitively, that rocket fuel you've mined and made in space will outcompete on price the rocket fuel launched from the Earth, even as launch prices are dropping dramatically. And so that's a first step. And so it looks like we are on our way to this virtuous cycle of industry growing and creating the capability to offload problems from our environmental burden. But it's going to be different when we move civilization beyond Earth into space. This is the structural difference that worries me. Every time in the past that our species has extended our range, we went to the new locations as a community. So we invented technologies, we invented clothing and shelter so that we could extend our range into cold environments. We invented boats and we invented social organization to make all of this possible, and we've been very successful as a species. But in the future, when we try to extend civilization beyond planet Earth, we run into this problem that the technology necessary to do that is so expensive that it prohibits most of us from taking part. Like, you need spaceships and rockets, and you need spacesuits. I've worked in this career my entire year, and I still don't own a functional spacesuit. Does anybody in the room own a functional spacesuit? If you don't, you can't go there. So we think it's mostly going to be robotics, and it'll start out with human operators, teleoperating with a time delay, but the autonomy will continue improving with artificial intelligence, and as it starts to grow exponentially, there will be ever more robots, but ever fewer human operators on Earth, to the point that labor becomes marginalized as a component of this industrial growth. That's never really happened before. And when industry no longer has its rate of growth governed by the availability of skilled workers, and it's no longer governed by the access to resources, because there's billions of times more accessible resources off the planet than there are on the planet, and it's no longer governed by real estate, and there's some measure of isolation from the structures we've developed here on Earth to govern these things, then we think it will begin to grow exponentially. And the models show that it can start to exceed Earth's productive value in a very short amount of time, like 20 years after the ignition point when exponential growth begins. Now, I've tried to analyze when does this ignition point happen. It depends on which scenarios that we can't predict. It might be as late as 2100, or it might be as early as 2050. I think the most likely scenario is that it'll happen around 2070, driven by geopolitical forces as nations scramble to control policy and resources in space. 2070, though, means we only have about 40 years to democratize this industry. Now, if we fail to democratize the industry, if it's owned by a handful of people that own the big aerospace companies, once they've achieved ignition, there is nothing structurally in the industry that would motivate them to dilute their equity. And so whoever owns it, as it grows exponentially, they will own it. And whoever doesn't own it will not own it and will eventually not have the ability to purchase a significant share. So if we want to finish democratizing it, we have to start right now. We've only got about 40 years to do it. The challenge is people don't really see it as a problem yet. There's no constituency really to tackle this problem. But honestly, I believe democracy will not survive the turn of the next century unless we solve this problem, because the tremendous wealth inequality that will happen when most humanity is limited by the planetary scale, but a handful of people are no longer. So that means we need to be asking the question, how can we create on-ramps for participation by all humanity so that when we figuratively go together into space, we will all go together and we will all be the owners and beneficiaries of this. Thank you.